In the math book that my students use for geometry, they are asked to memorize this formula for total area of a cone. Pi r s plus r, with the s plus r in brackets. It's not a pleasant task to memorize this formula because, let's face it, it's an ugly looking formula and it looks like the sort of thing that will be hard to remember. But the good news is that you really don't have to memorize this formula at all. The students are also required to know how to calculate the lateral area of a cone, which is the area just of the slanted outside part and does not include the area of the circle at the bottom. And that's an easy formula to remember, pi rs, with r being the radius and s being the slant height. Of course, they also are required to know the area of a circle formula, which is pi r squared. And the truth about the total area of a cone formula is that it is just a combination of these two other simpler formulas. That makes sense, because the total area of a cone is going to be the area of the slanted outside part plus the area of the circle on the bottom. The circle formula is the area of that same circle on the bottom. And the lateral area of a cone formula is the area of that same slanted outside part. If we find these two areas and add them together, we should have the total area. Let's prove it. In this example, the radius is 5 and the slant height is 20. So when I plug these numbers into this formula and use 3.14 as my approximation of pi, I get this. Pi is 3.14, r is 5, and s plus r is 20 plus 5. Of course, 20 plus 5 is 25, and 5 times 25 is 125. So we are finding the answer of 3.14 times 125. The answer to 3.14 times 125 is 392.5. For our unit, no units were given in this example, to keep it simple and because I'm running out of space on this whiteboard. But when I'm not given a unit when I do a math problem, I'd like to use the word unit as my unit. In this case, because it is area, I have 392.5 units squared. Now let's find the lateral area of the same cone. The radius is 5, the slant height is 20. The formula for lateral area is pi times r times s. So we have 3.14 times 5 times 20. Of course, 5 times 20 is 100, so we have 3.14 times 100, and the answer is 314. Again, we don't have a unit, so we use the word units, and it's units squared because it is an area. Now let's find the area of the circle at the bottom of the same cone. We don't need the slant height this time, but the radius is still 5, so the area of a circle, pi r squared, becomes 3.14 times 5 squared, which is 3.14 times 25, and that gives us 78.5 units squared. It seems that if I add the lateral area of the cone to the area of the circle at the bottom, I have to get the same answer as I got for the total area. Let's take another look at that total area formula. We have total area equals pi r, and then in brackets s plus r. If we use our polynomial skills for multiplication, we can multiply pi r by the contents of the bracket. Pi r times s is pi r s, which is the same as the lateral area of a cone formula. Pi r times r is pi r squared, which is the same as the area of a circle formula. Therefore, this pi r squared is the same as this one, and I can replace this with 78.5. And this pi r s is the same as this lateral area, and I can replace pi r s with 314. And if I add together 314 and 78.5, I get 392.5. Square units. So what this means is we don't have to memorize the total area for a cone formula. If we know our lateral area for a cone formula, and if we know our circle area formula, then we can derive this formula whenever we want it. And this formula can be expressed in this form with the bracket, but it can also be expressed in this form. Total area is equal to pi rs plus pi r squared, because this means the same thing. This gives us the power to not memorize a complicated looking formula in preparation for an exam. We can derive that formula in the exam when we need it.